The ability of having AI to extract data from body signals is going to be a major alteration in how medicine works. You have the AI looking at stuff that we can't see because there's just too much data. There's a limit to the human ability to process data. If I give you an ECG, it just looks like a big wiggles everywhere. You look at it and you're like, I have no idea what this is. And if you train people, they can look at it and detect things like alpha and gamma waves and stuff and detect other bits and pieces in that. But a computer is really good at detecting all of this and can deal with larger and larger contexts of data. And so once we move towards that, there's going to be a lot of interesting breakthroughs.
I'm Sarah Nagle. I've spent my career leading research and product development within some of the world's largest brands.
And I'm Chad Reynolds. I'm a serial entrepreneur and founder and CEO of Verve.
And this is AI Powered by People.
Each episode will dive into the latest AI developments and talk to an industry leader to help you better understand and utilize AI.
We'll take you inside some of the world's most famous companies and share examples of how AI is improving innovation, consumer engagement, media, and marketing.
No matter what industry you work in, we'll help you navigate one of the biggest disruptions to organizations and people today.
Hey, Chad, how's it going?
Doing great. How are you?
Hot. It is so hot here in New England. It's like we're in this major heat wave. It's been 90, hitting 90 every day. So it is pretty gross.
Yeah. I don't know. I'm down in the South, sitting on porches in my rocking chair, drinking sweet tea, just enjoying it down here. Come on now.
That sounds lovely. I need a little bit of that in my life right now.
0% of that is true. So if a laptop is my rocking chair, then sign me up.
You're nailing it. Yeah, nice.
Yep. We had a really huge podcast last week. Lots of listener feedback.
Yeah, it was one of my favorites, I think. I mean, we've had some really fantastic guests, but it was just such a unique way, I think, of doing an interview. And because part of it is yes, I help create her, but I don't know what she's going to say. It's like a real interview, you ask these questions and what she came back with, the creature or the animal is like an octopus and came back with a really cool answer and talking about different ways to kind of innovate in different ways. The brick idea?
Fit?
Brick fit idea. I thought was really cool. I thought that it was fun.
Yeah.
Should we do it again with other agents?
We should absolutely do it again. I mean, so some of the questions that I got, what was real in the interview? Was she actually responding in real time to what you're asking? And the answer is yes. The questions that Sarah and I were asking were, essentially in the chat, click generate, and and Amma generated the response and talked it. So all of that was 100% live. I think the only thing we ever edited out was maybe a second or two on the in between on the latency. But yeah, we had no idea what she would say. Well, I'd say we have an idea of what she would say because we had been prompting her all different kinds of questions to test through the testing process. But in that moment, we had no idea what she would come back with. So
yeah, I'd say we knew. I kind of knew how being kind of the type of personality and kind of it being a little funny or things like that. But specifically
just like a person just like a person generally how they're gonna respond maybe but not exactly what they're gonna say. So and sometimes they surprise you.
Totally.
Just like people. So
I have a question actually. So from went to school for industrial design, and one of my friends, Chris, follows the podcast. He's one of our
Hey, Chris.
fans. He texted me a question the other day, and I didn't know how to answer, so I'm going to ask you. So because Amma has memory, will she form judgments on the people she's interacting with? I.e., if you're rude with your questions or responses, will she kind of infer that you're a rude person?
I would say yes. So be nice. Be nice to Amma. I think the part about what we're doing is also teaching communication skills. And I know I mentioned this before. I always kind of cringe a little bit when I hear kids or adults kind of talking to Alexa or any of the other things in a weird, in a way that they wouldn't a person.
Like I talk to my 4.5-year-old sometimes.
Yeah, I just think, we're building interfaces that are audible, talkable conversations, that you're having. So I think, communicating in a civil way, or in I don't know, a productive way, I think is always good. You can obviously be short and candid and that, but yeah, I think I don't know. I know the questions we asked her were in, a format that we would ask a person. But I've noticed, like, if I'm kind of like being short, or like, hey, can you do it this way? Like, oh yeah, let me format it this way, or format it in this type of way. So it's always trying to be helpful. So I don't know if it's necessarily coming back as rude, but I know you had put into her personality,
She was
less
collaborative, and
yeah.
yeah.
So coming across as like a partner and advocate as opposed to a critic, I think was important. But
Or
yeah,
to
you
know that,
could.
like, I ask questions because I have, now that I think of it, I've asked questions like where I've kind of gone through a series where it's like they're not getting what I want, and I'll just kind of like put it in there. It'd be like, they're basically like, whoa, I understand that I'm not getting you what you need, and they start to ask me questions back to make sure that they understand like how to
Yeah.
give me the right answer.
Yeah, I mean, I know when we were, building her, we were using words like quantum, and some of the training of it, and then we were getting these very academic approaches. Or like, all right, like, even though we were getting it back, I'm like, hey, can you say this in a much more conversational way?
Yeah.
And so it's essentially taking that knowledge and then reformatting in a better conversation. I'm like, okay, that's the right style of communication we want.
Yeah.
Let's use those as some of the instructions. So, yeah, great question, Chris.
Well, we have a fun interview coming up with Dr. Ben Vaughan, who is our resident AI expert at Verve. We all at Verve reach out to him with questions. I know I ask him lots of questions because he's able to take really complex ideas and kind of synthesize it and kind of relay it back to me in a really human way that I can understand. And starting next week, we're going to be featuring a segment called Ask Dr. Ben, where he takes questions like the one Chris sent us and he answers them. And he is able to kind of break it down so everyone can understand. So we're looking forward to that with Ben. All right, let's get to the headlines. So, first up, the U.S. Senate Committee on Commerce, Science, and Transportation has introduced a new bipartisan bill called the Copied Bill, which stands for Content Origin Protection and Integrity from Edited and Deepfake Media. It's a mouthful.
It just rolls off.
It just rolls off the tongue there. It is to protect content owners and their work from illegal replication and abuse by AI companies. So it's requiring tech companies that develop AI models to allow content creators to attach machine-readable information documenting the origin and history of the piece of digital content to their work. I think this is a really fantastic bill. What do you think?
I think it's a really important bill. It's a long time coming, and I think it was really important to get into some of the advancements that are happening today and the details. I think all the details matter, and I think it'll add transparency into where some of this data is coming from and how it's being used to train models.
Yeah. I mean, we've seen so much of this in the media. We talked about it, I think, a few weeks back about the FKA Twigs, where she was like trying to protect herself by creating her own AI to be able to kind of, own her information, own her kind of what she's creating. We've seen the Taylor Swift stuff. We've seen it kind of across like Hollywood media, and it seems like there's been enough of these cases that now they're deciding, Senate is deciding to do something about it. So I think this is going to be a very welcomed bill, and hopefully it passes to be able to protect the stuff that people are creating, and knowing that that they're, or if it is being used, like they're being compensated for that use, which is really important. I know that we talk about that a lot, and we know that it's really important for, people to be compensated for, if they're participating in work like this.
Yeah. I mean, I wonder what it's going to do also for content creation of like, I think the last couple of decades have been much more about putting what like being a thought leader, right? So putting like what out on the web or podcasts or lots of different things. So I wonder how this is going to shape, if this goes through, I wonder how it's going to shape people's desire to create content as well. Because it's, there's the explicit, like, hey, Sarah, I'm going to take this painting that you made and I'm going to, train something completely different, like directly off of this in order to monetize it or sell your works without you knowing. Mm-hmm. There's something else to just being able to read Medium articles, and they kind of are thought starters for you that influence like decisions you're making, things like that. So that's kind of like the human experience, mm-hmm. and trying to distinguish the difference between that versus a direct kind of rip off of your work.
Chad, what might be the roadblocks or the pushbacks on this?
I think so I'd say I'd say within the bill, there are specific things that I think you can track and, claims you could file. So things like, hey, I created this artwork and I put my watermark or my signatures or everything over it. So it's clearly mine, unique and ownable. And then someone else took it and wiped all those things off of it and, is pushing it off as their own and doing many more things with it. Those are very distinguishable things that you can prove with evidence. Mm-hmm. Some of the others are a little bit gray, that I think those types of things may be harder to get passed through, because or else we would be filling our courts with all these different kinds of lawsuits of how something can be read by a person or by a machine and then replicatable, or it's maybe not word for word, but it's summarized in a different way. So Sarah, in related news, according to The Verge, the unofficial Apple weblog, which is known as Tuaw, is now publishing and using AI with old bylines of the authors of some of those articles. And I know you're sharing screen, but for our listeners, maybe you can share a little bit more about this story and what's involved.
The Tuaw, we'll call it Tuaw, shut down by AOL in 2015. And the writers that used to work there are finding their names on the site. It looks like they had written new articles, but so for this one, Christina Warren has not worked there since 2009. It has a description of her as a writer, but it is not her image.
And she didn't write the article.
Because the source information is all the articles she used to write. And then that was generated, kind of brought together as like a data set. And a new article was generated based on the way that she writes or the types of things that she's interested in. As this relates to the last headline, this feels fishy. I mean, this is her, she created that content, although it was, purchased by Web Orange Limited from Yahoo. It feels wrong. How do you feel about this?
Well, I guess where is the line? So maybe take us up to the line and what went over.
The line is where they started using her name. I think that if they bought all of the content, that's fine. It's the content from, this Tuaw, and, this Web Orange Limited owns it. That's fine. They can source the information or all the articles that Christina had written, but then the rewrite should be a different name.
I guess, is this a rewrite of the same article, or is it generating a completely new article, not even about the content, but the content about something else?
It is an article about something else, but I feel like it's also still in the space that Christina is an expert in. So first, I feel like she should be notified that her information is being sourced. But, as it relates to kind of the last one around the bill, she should be compensated for at least slightly, they're using her source information to be able to create this. But the line for me is using her name like that. Okay. That just kind of is like a misrepresentation of this person that used to work there. That you could put Christina Warren's name into LinkedIn. You can find her, know that she's a writer and she did all of this stuff. it just feels shady. Like that's the line to me. Name it whatever you want, and then she would have never found out about it. Or this wouldn't be a story.
Yeah.
Now let's get to our interview with Dr. Ben. We're really excited to have him on to answer our questions about AI. Are you ready?
I'm ready. Let's go.
Well, hey, Ben, welcome to the podcast. It's good to see you.
It's good to see you.
Well, Ben, we'd love to hear a bit about your background. You've got like a past with Verve, so we do want to hear about that too, but love to hear about, the type of work that you've done and your expertise.
Yeah, so I'm technically a trained mathematician. So I applied mathematician. I have degrees in engineering, computer science, and mathematics. And for, I guess, the last 15 some years, I've been doing research work, connecting the dots between mathematics, computer science, data, and problems in the real world. So I got my PhD from Northwestern University in applied math, and I was doing this research at the University of Michigan, as well as University of Oxford in England. So most of that stuff's been related to biological things, but I'm now in the recent 5 years or so, been working a lot with Verve and moving towards AI and how you can leverage a lot of these machine learning and AI tools to work with marketing and then other types of business related data.
I love how you just breeze over Oxford. Like I would talk about that if I went to Oxford. It's just so incredibly impressive. So can you kind of talk about the kind of some of the projects that you've worked on or kind of the areas of focus with Verve?
Yeah, so a lot of what I've been doing with Verve for the last few years, well, before LLMs, was just getting a lot of the concepts and the ideas and setting into the headspace of how can AI alleviate a lot of these pressures and pain points when dealing with things like consumer data. So like if you go out and you do a survey and you collect a bunch of data, you typically do it in a way that is easy to process. So you do like a survey and you do like the Likert scale, 1 to 5, type of thing. And then when you do that, it's easy to figure out what the results are. You just add up and take the average and say, oh, the average person said this was a 4 out of 5. The problem is that throws away all of the finer details, the nuance to it. Why did they say it was a 4 and not a 5? Why did they say it was a 2 or a 3? So like when you look at like star ratings online, you kind of run into an issue of, yeah, everybody said it was a 4, but really, is that good or bad? It's not clear. So you start to read them. And then that's where you get into the problem. When you start reading reviews, you end up finding out that there's like 10,000 reviews. So there's no way you could read them. So how do you deal with that? How do you extract the useful information from surveys where you really want to get finer detail? And so the great thing about Verve is Verve collects video data, which is great because it provides a lot of detail. You have like we have right now, where you have the voice, you have video, you have other sources of information in addition to the words that they're saying, as well as, hey, I like this, as I rate this a 4 out of 5. Having all of that is great, but it creates the problem of just this huge amounts of data. And so before, people would have to sit and watch them all. And if you collected 80 hours worth of video, some people had to sit for 80 hours and watch the video because you couldn't skip stuff. Because what if they said something important in the part you skipped? So that creates a major problem. You want good data. So you collect good data, but then you can't use it. And that's where the AI and machine learning and a lot of these new tools come in. And so it's kind of, it's one of the things about AI is AI often moves really fast and then goes really slow and then goes really fast again. And so 5 years ago, we didn't have a lot of these newer tools. And so we had to be very strategic about how we extracted information. So we created a bunch of algorithms. We got everything in place to be able to process large amounts of data. And then now this new paradigm with these chatbots and everything else have come out. And they put, Verve was in a good position to be able to adapt to those because they were AI ready when the revolution happened.
So when you talk about it going fast then slow then fast, can you describe what do you mean by that?
Yeah, so back when I got into AI, which was, nearly 30, almost 40 years ago, we were doing stuff. There was the very early introduction of things like neural networks, which mimic the brain and things like that. And most of the stuff was things like expert systems where somebody writes basically a big if statement. If this was true, you do this. And that was used for like doctors to help diagnose things. Like if you ever go into WebMD and it says enter your symptoms, that's an expert system. Some human being programmed that with using an expert, and then they created a set of rules to lead you down a path. But that stuff all came out quickly in the 90s and was made big deal. And then what happened was what they call it the AI winter. Basically, we couldn't do anything more. We couldn't figure. There was a lot of things that people couldn't figure out. There wasn't much money. There wasn't much computing power to do certain things. And then we had a stretch of multiple decades of very slow progress. Most of the progress was what's called statistical learning. How like Google Translate used to work, where it figured out what the most, some statistical prediction based on the likely words that map together to translate languages. So if you ever use like old Google Translate, sometimes it didn't translate well, but that was a flaw in that system. But then with the emergence of these GPUs, the graphical processing units, so you can thank video games for all of this, because these types of systems were invented to play video games back in the mid 90s, late 90s. And then people found out that you can do scientific research with them. And so I was doing scientific research in the late 90s, early 2000s with GPUs, and we could solve all kinds of interesting problems. And then they realized that AI, neural networks, work really well on these GPUs. And so now you have the computing power to do it. And so now that let us open the door. And then all of a sudden we started to get, a lot of amazing new AI advances in the last 5 years. Technically the last 2 years, the whole world of AI has changed.
And Ben, can you share maybe a little bit more about large language models? I know we talk about them often as far as how we're utilizing them, but curious how maybe those have advanced also with just the use of transformers around the data sets.
A large language model is just a sort of the new name for models that try to understand what's called natural language, or natural language processing. So, when you write code for a computer, you're writing it in a structured language where it has certain sets of rules and it's very narrow in scope. But human language is much richer. I can say the same type of thing a huge number of ways. I can use lots of different words. I can use correct grammar. I can use incorrect grammar. I can use I can mix languages. I can still convey something, but not in a very structured way. And so being able for a computer to understand natural language is a much harder task. And so people used to do it where they would just count words. So like if I said the word duck, you would be likely that you're talking about the animal. But then also you can mean duck in terms of, hey, something's coming at you, you need to duck. And so those having that flaw where there's lots of things like homophones and other ambiguities in language made these things not very good. And so they tried to learn better language using these neural network models, which are just, again, like the idea of taking how our brain is structured and write that on a computer. Once you start doing that, they were making some progress, but then it was hitting barriers. They just weren't doing a good job until they came up with this concept called a transformer. So that is a type of neural network that uses what's called attention, which is basically looking at what's going on around the words. Like when we read a sentence, if you have a word, when you're first learning vocabulary and you have a word that you don't know, the first thing you do is you look at it in terms of context. You look out around the rest of the sentence, and you then try to infer what it means from its neighbors. And introducing that concept into neural networks through a process called attention allowed the door to open up. And so you started to get these interesting language models that started off. They were actually almost all named after Sesame Street characters. So there's Bert and Elmo and those types of things, computer science and acronyms. So I guess if you're dealing with these things all the time, you kind of try to be creative to draw attention to it. But those types of systems did a lot of amazing things. And then that led to what's right now the GPT models, which is what, if you see Chat GPT or GPT 4.0 or something like that, that's what these are. These are what are more general transformers. The idea is they take a bunch of information and then they allow you to produce a sequence of words or tokens that you can write out. Okay, so that once we had the framework of how to make these models with transformers, it was just a matter of having the computing power and then dumping the data. And so basically the entire, almost everything that human beings have written that we know of that's on the internet has been sucked up into these models. And now this model learns so much more about language and then is now able to basically spew out all kinds of what seems to be reasonable text, prose, poetry, whatever you ask.
There was, kind of the technical advancement on that side, but also just like a very simple interface that people, anybody could access. Like anybody, like we all know how to ask questions. But it seemed like that, I wouldn't call it like an innovation because it was a very basic thing, but it was also introducing a very simple UI into the world that seemed universal.
Yeah, it's actually it's funny because you have this cycle a lot with computer science that things reoccur. So in the I guess this late 70s, early 80s, there were chatbots. They existed. What they did was they mimicked in a very crude way that type of interaction you have nowadays. And then also science fiction, you have like Star Trek, you talking to the computer and it talks back, that kind of thing. The natural interface of having language as your user interface is a big change in the paradigm because it allows us to not have to have as much technical knowledge to be able to interact with these types of models. Yeah, so it does have a big effect, but there's also some disadvantages with it. Again, natural language is often, ambiguous. It's not perfectly clear. And so it requires a bit of tuning to be able to communicate with them. But that's the same thing you have when you communicate with like employees or friends or new people you want to meet with. You got to learn how to talk to people, and we do it naturally. And it's the same kind of interaction we have to have with these types of chatbots.
So Ben, we've been talking about agents quite a bit. We released our first AI agent to the public, Amma, last week when we had her on the podcast as well. So related to what you were talking about with LLMs, how do AI agents kind of, interact with LLMs and kind of how does that work?
So an LLM really, it doesn't understand what words are. So if I say cat, it doesn't know what a cat is because it's never seen or interacted with a cat. It just has learned the concept of a cat. And the way it's learned is by predicting words. So if I say, I have a pet blank, you can think of all kinds of words that you might use to fill in. Dog, cat, fish, other animals. The idea, or even rock, but the idea is the large language model learns that there's a relationship between dogs and cats and fish based on the fact that it keeps seeing this pattern over and over again. The relationship between the concept of a pet, which it has no idea what pet is, and the concept of a cat or dog. Okay. So these basically learn by just absorbing so much information and then seeing these recurring patterns that occur. And then when you ask it a question and you say, what kind of pet should I get? Well, it learns that when you ask a question, what's the most likely word to response to that? Well, it might be, I think you should get a, and then it says, once it gets to that point, it says, what should I put in there? And it basically randomly chooses something based on the most likely thing. It might say dog, it might say cat. If you ask it the chatbot like 5 times, it might give you different answers. But it might even give you some odd, unexpected answer every so often. And that's how they work. They really don't understand. Well, we don't really know how they work, but we don't believe they understand what things are. They just understand that there's a relationship between them. Now, that said, that large language models have learned from every bit of data, everything. So from Moby Dick and Herman Melville to anime to news podcasts to Twitter feeds and people ranting on Twitter or Facebook or some other online platform. It's learned all of those things, which means when you ask it a certain question, it uses all that information to try to formulate its response. Well, the problem you have is that if you have bunches of different disparate domains that often contradict each other, when you ask a question, it has to somehow resolve which side of the thing it goes to. So you can often get LLMs to sort of change, how it's saying things or change its meaning in the middle because it doesn't know it lies right in the probability 50-50 coin flip. It should say one or the other. Okay, so that's one of the disadvantages with LLMs when you're dealing with very specialized tasks. And that's where agents come in. If you have an agent, the agent basically instructs the LLM to forget everything else around in its knowledge and focus on the domain you want. So if I want to have it talk to me like I'm a, mathematician and use mathematical terminology, very rigorous, very, concise, well-defined terminology, if I ask an LLM to do it in general, it might do an okay job if it's figured out that it should do that. But agents instruct it to do that. So then it wouldn't do as much vague or imprecise language. And so that's the power of agents, is that you have a specific task and you have an agent that's been trained for that task. You can get much better results than just asking a general LLM.
A lot of people have asked this question when we're talking about agents, where why not why not have a super agent that does everything? Why would you have specialized agents?
Yeah, so part of the reason is that, kind of like how I was saying, that there's so many disparate things. And if you were asking for something that's, let's say you ask for a task that say you want to communicate to a specific demographic in a language that they're used to. So like maybe young people who have a specific set of slang that they commonly use. If you want to have the LLM communicate with them in that way, it has the burden, though, of having every other way of conveying that information there. It's kind of like if you want to, you have a box of crayons and you take all the information from the crayons, all the colors, and you just melt them down to one giant crayon. Or maybe you cut it up and weld it together to where it's like a rainbow crayon. And you try to color a picture, you might either get just brown, just the average of what everybody would say, or you might get snips of different color, different places where you don't want it. Okay. Whereas if you do an agent, what you're doing is you're separating all the colors to get to the one specific color you want. So if you want to communicate to, say your internal marketing team using internal marketing language, you pick an agent that does that. It extracts that one color from the box, colors with that. Then you take its output and say, well, I want to use that to go to market. So then I take out a different crayon. Now I can draw that part of the picture using that. And so agents, if you create a good set of agents, they allow the LLM to be even more powerful.
Yeah, and Ben, in the agents that we're launching, obviously we've got different types of agents, where you've got agents that are focused on some of these internal tasks, right? So the writing marketing copy, or writing content, or visualizing a product concept. You have these other agents that could also be reflective of consumer segments. And one of the unique properties, I guess, of what we're doing is that we're using the video survey as to collect a really unique data set that isn't in an LLM. And I'm wondering if you could share a little bit more around the strengths of having that that data set as training data to create the instructions for the agent, and why that might be powerful. And I love the crayon analogy. Like, I think it just kind of hammers it home for everybody to understand the value that agents can provide. So
yeah. So there's another part of this people don't talk about a lot with AI right now, in terms of what people are seeing in the news and such, which is the data. So, right now LLMs have been trained from everything on the internet, but it means it's been trained from everything from a snapshot of the internet at some point. So when you train ChatGPT-4, it was trained, and once it was trained, it doesn't actually have the information from anything new. So you have news events, things that happen that you would like. Who won the NBA championship? It wouldn't know in the straight up LLM that who did. The last one was even farther into the past than what you might be asking for. And so having data, especially fresh data, is really important. So like if you create an agent to say you want to talk to, 20 some year olds who are going to buy their first car. So the LLM has learned all of that stuff from the history. So it's probably had stuff from 2010s. It's probably had stuff from during COVID. It had stuff probably from the 90s and the 2000s in that data set. But what if people's views on buying cars now are different? LLMs have to have fresh data. And that's one of the challenges with them, is that how do you have to retrain these things, or you have to insert that additional data. And that's one of the benefits of having the video surveys, is that you have data that has a couple really good properties. One is it's targeted data to what you want. If you want to learn about their opinions on buying a car, your first car, you ask them about it and you get the responses about that. There's not as much noise, okay, that the LLM has to sift through to figure out what's going on. The other thing is that it's new data. It's data that's current, that you've asked to it and people have responded now. So it's giving you fresh data. And then the last one is it's verifiable data. It's somebody talking and you can look at them and you can see them and you know that they did this, that this is not some other entity like a bot or somebody who's trying to poison the waters. This is real people that you can communicate with. And so when you collect that fresh, verifiable data that is really targeted to a task at hand and you create an agent with it, it becomes even more powerful than just, trying to create an agent using the LLM's data set. And so that being able to, go and ask, you go and ask 50 people about their opinions on buying a first car, you might get a disparate types of things. But if you want to talk to them as a single entity, well, that's how you create an agent. You create a persona that combines all that information. And what it does is it smooths out some of the variations, but they're still there. And you can talk to them and find out, hey, what is the most common thing? And what if you had to think of something that's a bit outside of the norm? Well, then you can still extract that information. But it's really key to having fresh, relevant, verifiable data.
Yeah, I mean, it's almost like if you're creating that chartreuse colored crayon, that it's also attached to the creator of the crayon, like the creator of the color. Why did you make it this way? How did you do it? When did you do it? What does it mean? What was your inspiration? You've got this like very specific knowledge base that also comes with it. Mm-hmm. That you can query the creator of it, which seems extremely unique from like an insight generation or creation perspective.
Right. And it also allows for the ability to follow up. LLMs, you have their data set, you ask it questions, it gives you responses. Hopefully you can find out what they call groundedness, where it got that information. Did it just make it up, hallucinate, or did it actually have some basis? But you also have the ability to, with this video data, these types of video surveys, to verify and say, hey, I can actually hear this person and see them talking on video saying that exact thing. I didn't have to watch 3 weeks worth of video to find this. It was the agent found it for me. And then I can follow up because this is a person. I know who they are. I can go and ask them again and say, hey, we thought this was interesting. Can you tell us more? And that ability is a game changer because it provides verifiable information and allows you to just get deeper and deeper into something, which you can't get with a straight up LLM.
What are what is the most common question that you get from people? And
yeah, so some of the questions are it depends who asks me. Like some of the more casual ones are, is AI going to kill us all? Everybody talks about that.
What do you say?
Don't answer the question with petting a cat on your lap, because then we're going to get some
Yes. my Bond villain.
Yep.
Yes, I'm creating the next Skynet. Now, so there's a lot of bit of popular culture. So in that case, there's a lot of popular culture bits that AI is going to come in and disrupt the world in some negative way. And there's going to be some disruption from AI, depending on how people go about using it. But, people often will say stuff about, hey, is it going to come and take over the world, or we're going to have robots everywhere? And that's not very likely, just from the cases that just because something is might be capable of doing it, doesn't mean we will give it the keys to do it. Because most of that type of fear of AI comes from the factor of trust. So we have something we don't understand. that can do these amazing things that can change the world. You might be afraid it's going to take your job, or it's going to do like traffic cameras and take over and start giving out tickets to random people. There's lots of these things where we give the machine the ability to do things and interact with our world in some way, and we get scared because we don't trust them, because we don't understand them. And that's really a big part of the AI fear. We don't want to give the keys to things, to machines. Now, that being said, we do that all the time. We very frequently will, give the keys to really dangerous things to people. So like if you think back, Terminator is a very nice movie in the sense of it's the intersection of this fear of two different world-changing events. The one, atomic weapons, from the 40s, and then AI, which, in the 80s was like this, thing that's in the far future science fiction. But now people are really like trying to make, an AI system that just runs everything. And you intersect those two things, you kind of realize that it is the trust issue. We had these weapons that could, destroy cities. How do we trust people not to do those? And it's the same type of thing with AI. So AI, how do we trust, if we give the AI the ability to do something, how do we trust it? And the easiest thing to do is to not give AI the ability, because AI right now cannot create its own ability to interact with the world. It feels like a person, but we're also very used to chatting. We chat with people all the time that we never see and physically interact with. It's like this conversation right now, technically I might be an AI. You don't know. But the idea is that the AI can't interact with the world in a same way we do. Like we can physically touch things, we can physically see things, but we can also smell things. And those types of inputs AI currently doesn't have in terms of these large language models and things. So I don't have much fear of, AI in the short term. In the long term, their capability, you can't really predict the future. But as long as we're always asking the question of how do we know we can trust these things, I don't think there's a major, fear for AI taking over the world.
So Ben, what are some of the innovations that are happening in the world of AI that are most exciting for you right now?
Well, right now we had the wave of innovations just a few years ago, where you had things like ChatGPT come out, and then you had things like DALL-E and Stable Diffusion come out that were able to create content easily. Was a major breakthrough. But the innovation nowadays is those types of things tend to be incremental right now. But the real innovations I see right now are the ability to take those big tools that are really not very well suited for specific tasks. They're just really good at doing one or two things and adapting them. The ability to take and use like an agent to be able to do a specific task with these bigger tools. The ability of people who might not, like small businesses that might not have access to art departments, to be able to create better, artwork and assets than they might have on their own. Or if you're a small business owner and you're not good at finance, being able to have an agent or some other system, AI system, that helps you do financial projections. A lot of people I talk to that are, small business, they don't know how to do their financial projections, and having that knowledge, to be the ability to do that without having to have a large amount of resources to invest in bringing in people in to do those, is going to be a bigger innovations. I think there's going to be a lot of innovations when these types of models move into the healthcare sector. Right now, healthcare spends a lot of time where humans find patterns and things, and being able to leverage the ability of these AIs and machine learning tools to be able to help us find patterns that can then, detect, what's called subclinical disease. So if you go to the doctor, typically they're like, oh, well, you did a test, you now have diabetes. Well, we're now going to treat you, but it would have been better if we would have found out a year or two before. Or you have AFib, you've had an episode, atrial fibrillation, you have to have a pacemaker or some other, treatment, ablation or something. And if we would have detected that 6 months ago, we could have prevented any of that damage to your heart. And so being able to detect subclinical disease is going to be a big innovation. And these AI models that work with a pattern in language also have the same abilities in dealing with other types of data, the hidden pattern in, say, your ECG that a doctor might not be aware of.
And so are those things that, like, up till now have been, I'd say, like, outside of the body, from a sensor detection, a measurement, like some way to connect to the AI. I guess, when does AI go inside the body?
So that's a trust issue again. If you have AI, if you say put AI in your body, a lot of people
are you ready for that, Chad? Do you want AI in your body?
I'm not sure yet. I'd definitely be open to it. I mean, I think I want to know. Right now, I'm using my brain in my, to tell, and like your nervous system to like send signals to my brain to tell me that I don't feel well or I do feel well, or if if I'm tired and But it would, like, are there other systems at play that could also help guide me? Because my brain is only one source.
Mm-hmm. Yeah, no,
there's Ben has to say about this.
Oh yeah, no, there's so I want to differentiate AI in the sense of AI altering your body,
right,
versus AI detecting things in your body. So most, we've actually have AI in our bodies, and some people do already, or at least something that you might argue is close to it, like a smart pacemaker that is able to detect when it needs to do the shock. Mm-hmm. Before, it was a simple thing, but if you input a microprocessor in there and you put some AI, some detection code in there, it can detect it. And so those things actually do exist, but they are not always, as advanced as they would like. But the ability of having AI to extract data from body signals is going to be a major alteration in how medicine works. Because most of the time, like if you have cardiac issue and you go to the doctor and you don't have the issue, like if you have a palpitation, you go to the doctor, it's not there. So how is the doctor going to know? You do ECG, oh, nothing came up. And the idea is they give you Holter monitors, the monitors you wear for a couple of days. But being able to take that data and not have to have necessarily a human be the only one who looks at it and says, oh, there's a PVC here, premature ventricular contraction. You have the AI looking at stuff that we can't see because there's just too much data. There's a limit to the human ability to process data. If I give you an ECG, it didn't just look like a big wiggles everywhere. You look at it and you're like, I have no idea what this is. And if you train people, they can look at it and detect things like alpha and gamma waves and stuff, and detect other bits and pieces in that. But a computer is really good at detecting all of this and can deal with larger and larger contexts of data. And so once we move towards that, there's going to be a lot of interesting breakthroughs. And then the movement towards subclinical, finding things that are negative beforehand, is going to be a big groundbreaking change.
Yeah.
And then being very accurate about that prediction. That way you don't predict somebody's going to have something and they get treatment and they never were at risk. But
yeah, I mean, especially with having, specialized agents at play that are looking at, they're experts in those specific domains, that are looking at a granular level at the data it's giving, but also generating potential solutions and working together across multiple agents of kind of like your body agent. And what does that look like, and how to communicate it to you in a knowledge that makes sense, or a way that makes sense, as opposed to doctor speak, which is, I'm just going to communicate the way I communicate to you, and I hope that you hear it. I hope you take it. But we all process information differently, and I think that's just a really interesting way to look at how not only the color of the picture, but also how to present it to someone else as either abstract art or a portrait of themselves, something that they'll kind of cherish. So it's fascinating.
Well, Ben, thank you so much for coming on, and we're really looking forward to your segment that's going to be coming up next week.
Thank you.
Yeah, thanks, Ben. Well, Sarah, that was a great interview with Ben. I know we're going to have many, many, many more segments over the following months to dig into these AI topics. So really excited about that. And then to follow on last week's agent drop, we have our next agent that's dropping today as well. For those listeners who are excited to try out Amma and then our next agent, go to verve.com and you can sign up. At the top, click on Agent Drops, where you can sign up to meet the next agent. So we don't spoil the surprise, but every week we're going to be launching a new agent. And if you have ideas or agents you want to drop, contact Sarah and myself. You can go to our LinkedIn page or also email us through the show notes.
Well, that's going to do it for this episode of AI Powered by People. The show is produced by Steve Berkowitz and brought to you by Verve. Thanks for listening. We'll be back next Tuesday.